For part 2 of this week on our discussion of categorical data, we will look at contingency tables for two categorical variables. So let's look at the Titanic data set again. So as we talked about earlier, in 1912, the Harvard graduate John Jacob Astor and his wife, they boarded the Titanic. He didn't survive, but we might ask, did his wife? Let's examine the Titanic data set again. So this is the data set where the rows are passengers, those are the cases, and the variables, they're characteristics of the passengers. So we have whether or not the respondent or the passenger survived, their gender, their class, what passenger class they were on, and then we also have their name. So let's look at these rows of 11 and 12, and you can see that we have John Jacob Astor and his wife for those two rows. And you can see in the survived column, for the variable survived, John Jacob Astor, he didn't survive, but his wife did. So this raises some questions. He was an upper class man, and so you might wonder, his wife survived, but he didn't. So were men more or less likely to survive than women? If you just look at John Jacob Astor and his wife, which really can be viewed as like a bit of anecdotal data, if you just look at those two rows, you might wonder, well, were men less likely to survive on the Titanic than women, or what was really going on? You might also ask, were upper class passengers, were they more or less likely to survive than lower class passengers? Because if you just look at John Jacob Astor, you might say, well, upper class passengers were less likely to survive. They're more likely to die on the Titanic. So these sort of little bits of observations, they can really guide us or sort of provide an impetus to answering certain questions. But in general, you want to use the full range of the data. You just don't want to look at two rows. And one way to really look at the data and answer these kinds of questions is to use tables and graphs, in particular contingency tables. And so we're going to look at two categorical variables from the Titanic data set to analyze what's going on. A contingency table, it's also called a cross tabulation. It's simply a table of counts or proportions or percentages from two categorical variables. The reason it's called a contingency table is that it can tell us how the cases or the rows of the data set are distributed along each variable, contingent or conditional on one or more categories of the other variable. So that's why it's called a contingency table, and we'll talk about the idea of conditioning in just a moment. So here's a table of counts, a contingency table of counts. Each cell in this contingency table will represent the number of times a particular combination of variable categories occurs in the data set. And the rows of a contingency table of counts, they're the categories for one variable, and the columns are the categories of the other variable. One thing to keep in mind is that the totals for each row and column are given in the margins. So here is a contingency table of counts for surviving the Titanic and passenger class. So these are all observations. The row variable is labeled here, and it's passenger class. Then the column variable is whether or not the person survived. We also have the categories or levels of the variables survived labeled, and then we also have the categories or levels of the variable class. In the middle, you can see that we have cell counts for each combination of the categories of class and survived. For example, if you just look at the row for the level lower and the column for the column yes, for that value of the survived variable, you can see that we have 131 people in our data set who were a passenger in the lower class, yet also survived the Titanic. To give another example, if you look at this cell, we have 103 people in the upper class who in fact didn't survive the Titanic. We can also see that we have marginal totals, because those are the margins, for each of the column variable. And then we also have, for example, in this case, a total of 618. So if you just add up 369, 146, and 103, the different counts of observations for that column, we get that margin total of observations. And then it's the same for the next column. So for this column, we have 427 observations. If you add up 131, 115, and 181, we have 427 people who survived the Titanic in total. In terms of the row margins, these give the total counts for the categories of the row variable, meaning passenger class. So we have 500 people in the lower passenger class, 261 people in the middle passenger class, and 284 people in the upper passenger class. To give an example, we have 369 plus 131, 500 people in the lower class, right? We have 284 in the upper class. All we're doing is we're just adding these row observations. Now this cell in the lower right-hand corner, that will give you the total number of cases in the data set. So here we have 1,045 passengers, right? One thing to keep in mind is that the column totals, they equal the total number of cases. So if you add 618 plus 427, you get 1,045. In a similar way, if you add the row totals, meaning the totals for each level of the class variable, you also get 1,045, the total size of the data set. And finally, if you look at the cells for each combination of the two categorical variables, those counts also equal the total sample size. And that's quite useful. Just to emphasize, the reason these totals in the margins are called marginal totals is because they are in fact written in the margins. Here's an example of the contingency table without margins, and here it is with margins. To just calculate if you're just given the contingency table without the margins, to create the table with the margins, you just add up the counts for each row and for each column. And then the lower right-hand corner is simply adding up the totals in the margins. You might also encounter a contingency table of proportions or percentages. Often it's useful to express a contingency table in this way because people want proportions or percentages when they're looking at these tables. To convert a contingency table of counts or frequencies to a table of proportions is very easy. You just divide each cell in the table by the total number of cases or observations. And then to create a contingency table of percentages from proportions, you just multiply each cell by 100. So here's an example of converting from counts to proportions. All we're doing is we're taking for this cell, we have 181 observations, and we divide by the total number of observations, and we get this proportion of 0.17. And then to convert from proportions to percentages, again, we just multiply the proportions by 100. So 0.17 times 100 is 17%. So we have 17% of passengers on the Titanic who were a member of the upper class and survived the Titanic overall. Now, when you're creating these tables, it's useful to kind of come to conclusions. So what we found from this contingency table of percentages is that most passengers overall, they didn't survive the Titanic. 59% people didn't survive, 41% of people did. So you can see that John Jacob Astor was actually among the majority of passengers on the Titanic because he did not survive. In a similar way, only a minority of passengers were in the lower class. So most people were, in the upper class, most people were in fact a member of the lower class or the middle class. A relatively small percentage were in the upper class. Another sort of conclusion we can make is about the sort of joint combinations of the levels of the two categorical variables. So we can say, for example, that 35% of passengers didn't survive and were a member of the lower class. To give another example, 70% of passengers overall were a member of the upper class and did survive. Right? Now, from this sort of basic contingency table of proportions and percentages, people often want to ask about relationships between these two categorical variables. So in particular, you might ask, well, we want to know if upper class passengers, are they more or less likely to survive than lower class passengers? To put it another way, we want to know the percentages conditioning on particular values, because so far we know the overall percentages, and we know the percentages for particular combinations, but we want to condition on some set of values and calculate the percentages that way. So the key point here is that often the questions you want to ask and answer from a contingency table involves conditioning. And again, this is why contingency table is called contingency table, because often you want to condition or you want to say things that are contingent upon the values of another variable. So for example, a question that we really want to ask is, among those who survived, what percentage were in the lower rather than upper class? In a similar way, but in a distinctly different way, we might condition on passenger class. So you might say, among those who were in the upper class, what percentage survived? So let's look at a contingency table in which we're conditioning on survival. What we do is we divide the cell counts by the corresponding total for each category of the survival variable, and then we multiply by 100. This will give us the percentages conditional on survival. So you can see that we have the total for this survived category. So we have 618 people who did not survive and 427 people who did survive. And when we divide each cell by its respective column total, we get these percentages. So you can see that we have these different percentages conditioning. Now, to really look at this, it's useful to look at particular cells and understand how to interpret it. So for this cell, we divide 369 by 618. 369 is the number of counts or observations for those in the lower class and in those who did not survive, and 618 is the total overall of those who did not survive. And this percentage will tell us among those who didn't survive, 60% were in the lower class. In a similar way, we know that 24% were in the middle class among those who didn't survive. We're just taking the cell counts for that for a particular cell, and we're dividing by the total number of counts of people who didn't survive. To give another example, we know among those who didn't survive, 17% were in the upper class. And again, among those who survived, 31% were in the lower class. Among those who survived, 27% were in the middle class. And among those who survived, 42% were in the upper class. When we condition on survival, we can conclude that among those who didn't survive, most, in fact, were in the lower class. As well, among those who did survive, most were in the upper class. So this suggests some kind of relationship between surviving the Titanic and one's passenger class. Now, a sort of different approach is to condition on passenger class. What we'll do is we'll divide the cell counts by the corresponding total for each level of class and then multiply by 100. So this is just sort of converting from counts to percentages. Let's go through a few examples. What we'll do is we'll take the cell count for this particular combination, which is 369, and divide it by 500. Okay, and that is just the total number of observations overall in the lower class, the number of passengers in the lower class. And this will tell us among those who were in the lower class, 74% didn't survive. So conditioning on class, we know that 74% did not survive among those in the lower class. Among those who were in the lower class, 26% in fact survived. Among those who were in the middle class, 56% didn't survive. In a similar way, we know that among those who were in the middle class, 44% survived. And then again, among those who were in the upper class, 36% didn't survive, and among those in the upper class, 64% survived. So conditioning on class also suggests a relationship. We can conclude that among those in the lower class, so conditioning on that particular value of passenger class, most people did not survive. And again, among those in the upper class, most survived. So both of these sort of conditioning events suggest a relationship. We can say that passenger class and surviving the Titanic are related to each other. The way to really think about this is that since the percentages for survival are contingent or conditional upon passenger class and vice versa, these two variables are in fact not independent. If these two variables, passenger class and surviving the Titanic, were independent, then the percentage, more or less, of surviving would be the same for all passenger classes and vice versa. So we have this relationship, and when we talk about this relationship, it's also useful to kind of talk about distributions. A distribution is simply the arrangement of values of a variable showing their relative frequency, meaning their proportions or percentages. So we think of distributions all the time. So suppose you order a large pizza, you're with your friends, and you have 8 slices on the pizza, and you have to distribute these slices among your 3 friends. So when you make this sort of distribution, you can talk about a distribution that is unconditional or marginal, joint, or conditional. So when we look at these contingency tables, it's useful to talk about it in a way that references the idea of an unconditional joint or conditional distribution. So here's an unconditional distribution of class that we've highlighted. And here's the unconditional distribution of surviving the Titanic. The joint distribution is given by the particular cells, and this adds up to 100. Conditional distributions are given here. The distribution of class conditional on not surviving, and then we also have the conditional distribution of class conditional on surviving. And then we also have conditional distributions of survival. So when we condition on this particular passenger class, we have this distribution of surviving. And then we also have a conditional distribution of survival, and another conditional distribution of survival. So the whole point about these distributions is that it's another way to talk about a contingency table. The key points for this part in our discussion of categorical data is that contingency tables can be used to examine the relationship between 2 categorical variables. When there's a relationship between 2 variables, we say that the 2 variables are not independent. And finally, distributions can be talked about in a way of being unconditional, joint, or conditional. And that concludes our discussion on categorical data as it relates to contingency tables.